Very happy morning to everyone of you guys. Now we are just going to see the thermodynamics, the next problem. Okay, so it means I think so. If you haven't seen the previous things about the problems, I do request you to go and watch once again. Okay, so this is just a continuation of the previous thing. Okay, so wait. So okay, guys, let us get started. So without wasting time, let us get started. Okay, so let us start with this problem. Okay, so just zoom a little bit. Okay. Okay, so you can see, just as go, you can see work is done on the adiabatic system, due to which adiabatic, okay, q equal to 0. So velocity v1 equal to 10 meter per second, v2 is 20 meter per second. So elevation increases by height, delta h is 20 meter, temperature delta T increases by 1 Kelvin, mass is 10 kg, CV is 100 joule per kg Kelvin. Okay, act gravity. Okay, if there is no change in any component energy of a system, the magnitude of the work. Okay, W they are asking. Okay, so simple concept, it means Q equal to W plus of delta U. So you can see delta E will be okay. Here Q is 0 and W equal to minus of delta E. Okay, suppose let us keep the minus as it is separate. So you can see work is done on the adiabatic system. Okay, so since work is done on the adiabatic system, so you can see the total work done, the magnitude, they are asking the magnitude. Okay, work is done on the adiabatic system, so it will be minus. Okay, so change in internal energy plus change in kinetic energy plus change in potential energy. Okay, so this is mcv of delta T plus of 1 mcv of delta T plus of 1 by 2 c mv square. Okay, this one mass mv square plus of kinetic energy mg of h. Okay, so you can see m is how much, 10 kg. So v square is given. Okay, 10 kg into this one 100 joule per kg Kelvin, so into of 1 Kelvin plus of mass is 10 kg, velocity is v square, so 20, so 10 meter per second the whole square, so plus 10 kg into 9.81, so 10 meter per second square into height is 20 meter. Okay, so now put, it means how we just put each and everything, we'll just get the directly an answer. Okay, that's it. Simple question, I think so you can understand. So question number 16. Okay, minus 4.5 kilojoule. Okay, that's it. Okay, I think so you can understand. Next thing is this one. Okay, so we need to just go soon, guys. Literally we are just spending a lot of time here. So next one, well insulated. Okay, well insulated means Q equal to 0. Rigid volume given. Okay, 1 meter cube. Mass is given 1 kg. Cp given. Okay, Cv given. Pressure is given. Okay, 10.5 Pascal. A stair is rotated constant. So 100 rotation and torque. Okay, 1000 rotation the final temperature. So well insulated means Q equal to 0. So what will be the thing? Q equal to W plus of delta U. So Q is 0, so W equal to minus of delta U. Okay, so since it been changing only, so this is mcv of delta T plus of torque into theta. So rotation is 2 pi n divided by 60. Rotation per second. Okay, so m is 1 into cv is 800 joule per kg Kelvin into temperature. So wait, temperature. So delta T means T final minus of T initial plus of torque is how much? 100 Newton meter into 2 pi into 1000 divided by 60. Oh, it is contain rigid volume. Okay. Wait guys. Since it is rigid volume, definitely work done will be 0. What is the T initial? So PV equal to MRT. Okay. So now before the condition, the pressure is given 10 power 5 Pascal, volume is given 1 meter cube into 1 kg into R is this ideal gas. So means CV is given and CP is given. So CP minus of CV equal to R. So 1000 minus of 800 is 200 joule per kg Kelvin. So this temperature is T1. Okay, find the T1 and after that put here and we can just find the T2 TF. Okay, 17. So you can see this one. Okay, so T2 equal to theta is how we can say theta equal to 2 pi n divided by P1 V1 divided by R. Okay, P1 V1 divided by R of T. Okay, yes, okay. This one will be mass will be 1. Okay, into torque is 100. So theta is 2 pi. Okay guys. So theta divided by 61 come and theta is 2 pi of n. Okay, and calculate and everything will come accordingly. Okay, I think so you can understand. So next thing we can just go 18th. Pure substance pressure is given 8 megapascal, temperature is given 400 degrees Celsius, specific internal energy del U 2864 kilojoule per kg, specific volume 0.03432 meters cube per kg, specific enthalpy yes, it's a good question really. Specific volume, specific enthalpy. So suppose in my point of view, so PV equal to nRT. Okay, specific MRT. So volume, so specific volume equal to R of T. So in this one, if we calculate the T1, so what is the specific change of enthalpy? Delta H equal to mCp delta T. Okay, Cp do we know? No. So delta U is mCv of delta T. Okay, so that's a good question in my point of view. Pressure, temperature, okay, specific internal energy. So by this, okay, by chance we can calculate R of T. Okay, suppose for example, let us suppose R of T we have calculated. Cp minus of Cv equal to R. Okay, Cp equal to R plus of Cv. Okay, so okay, see for degrees, so you can by this we can just calculate the R, put the R here. Okay, by this we can calculate the Cv, but anyways Cv, simple concept only, we are making a mistake, I think so. 18th one, definitely guys, simple question, but see, as I just told about simple question, we are just making it complicated. So h equal to u plus of pv. Check. So 2864 plus of 8 into 10 power 3 and put each and everything. That's what I'm just saying. We are just making a simple calculation, simple thing only. Okay. So you can just go for the next question. Yo. Come. Akase. So come. So next question you can see, certain ideal gas is initiated to P1 and T1. Okay. First it undergoes, it means this one pressure volume, constant pressure process. Okay. And T1 is T1, T2 is 3T1 by 4. Okay. Next it undergoes constant volume. Okay, this is constant volume. So 2 to 3. Here the T3 is T1 of 3. Okay. The ratio of final volume to the initial volume. Okay, they are asking this V3 equal to V2. This is how this one. So you can see V1 V2, so V3 equal to V2. Okay, so generally V2 divided by V1 we need to calculate. Okay, so based upon temperature, so you can see constant pressure, so PV equal to M or T. Okay, so this constant, so this pressure is constant, so V1 by T1 equal to constant. Okay, so V1 of T1 equal to V2 of T2. Okay, but final volume is this one, so we need to take 3 so V3 of T3. Okay, just 1 second. So PV equal to M or T. Okay, so volume motion P equal to T, so P divided by T1 equal to P2 divided by T2. Okay, so since okay, so V1 is T3 divided by T1 equal to V3 divided by V1. Okay, T3 is how much? T1 divided by 2. This one is T1. Okay, so T1 is equal to 0.5. So 1 divided by 2 is then we are just doing any kind of mistake, I think so. So let us go like this: V1 of T1 equal to V2 of T2. So you can see V2 divided by V1. T2 is 3T1 by 4 divided by T1. Okay, T1. So 3 of 4 is 0.72820 Okay. But V2 by V1 is 0.75. V2 or V3. Okay. So answer may be 0.75. 19th one. Okay, that's the answer. Okay, we can just go for the next one. So next one you can see the specific, I think so you can able to see this one. So specific heat is CP they just given, so equal to 17.49 24.77 into 10 power minus 3 of T. So what is the change of enthalpy? So enthalpy changes mCp of delta T. So M is generally 1 kg, just put the specific enthalpy. Okay, specific enthalpy. So Cp is 17.49 plus 24.77 dH divided by dt. This temperature means dH. So this dt delta T will be, this one is temperature into dt. So what is the thing? 25 degrees Celsius. It means Cp is given as temperature in Kelvin. Okay, so you need to write this one 25 degrees Celsius plus 273 Kelvin. Okay, this one 700 degrees Celsius plus 273 Kelvin. So put 17.49 of T plus of 24.77 of T square divided by 2 will come. Put the value here and you just calculate. That's it. So So not a bigger case thing, so just a simple thing. Okay, I think so you can able to see this one. Okay, calculate, answer will come. So next thing, 21st one, this one. So a closed rigid vessel, okay, then volume, so work equal to 0. So air is initially at pressure given, volume given. Okay, it means state supplies, we are just giving what to the air. Just 1 second. 100 kilojoules of work to the air. Okay, 20 kilojoule of work is state supplies work in done. Okay, so then here work is displacement work plus of shear work. So displacement work is 0 but shear work is there. Okay, that's it. Q equal to W plus of delta U. So work is done on the system. Okay, heat is supplied, this one positive, 20 kilojoule equal to minus 100 kilojoule plus of delta U m CV of delta T. Okay, mass whether they are given. Okay, so PV equal to MRT. Okay, pressure volume with the R is given as R is gas, so R is 0.287. that will be calculate the mass. So after calculating the mass, again you need to put, because see this is rigid mass. Okay, inside the mass definitely mass of air will be, so CV of air is how much? 0.718, I think. So this one, what is the value? What is the value of 0.21 something, 287 something will come. So put and calculate. Okay, that's it. I think so you are able to understand. 21st. How work is 0? We have just it means you can see guys, we just steered, we are just doing the steering work. So definitely by steering you certain kind of work will just go on. Okay, so in my case this is literally not possible. So why I'm just telling is, you can see first which one will just say, let us go for C. Which one is the 11th one? You can see this one. So parallel way this has been rotated, and same way here we are just, as this has been rotating, it's been supplying 100 kilojoule of work, means definitely it should be but anyways, I think so you understood the concept. Okay, so I think so we can just go for next one. So I'll just recheck this one and I'll just tell to you. So 21st, recheck this on there. I'll take my ball pen. So next question you can just see, a thin insulating member separates two tanks initially fill nitrogen, CV, carbon dioxide. Okay, the member, the gas are allowed to mix in homogeneous during this process. There is no heat or work. Okay. Okay, this is a normal thing only. I think so you can easily do it. This one. So perfect insulation. Okay, so here the delta U alone will be the equal to 0. So delta E equal to m c v of delta t plus m c v of delta t of particular thing. Okay, so how we can just calculate the mass of this one? So n equal to mass divided by molar mass. Okay, so molar mass of nitrogen is 28, so 0.8 into 28 equal to mass of nitrogen, and for carbon dioxide 0.2 into, for carbon dioxide 44 I think so. So 16 32, carbon is 12 I suppose, equal to this one is carbon. So calculate this mass, put here, and you can see delta T will be, you can see here definitely the temperature will decrease. Okay, so T initial minus of T final plus of this one T final minus of T initial, okay, equal to 0. So calculate this one, we will just get the final volume. 22. Okay, T of nitrogen minus of T of final, and T of this F minus of T of CO2. Okay, we will get this answer. So next one, so you can see this is okay, 300 Kelvin, this one 400 Kelvin, P to P. Okay, pressure to pressure CV and C. Okay, the chamber A contains a mixture of 0.5 kg of nitrogen and 0.5 kg of helium. That is okay. Here the pressure, the gas rupture, it means assumed to be ideal. What is the ratio of volume of chamber? Oh, they are asking the volume. So volume of chamber A divided by volume of chamber B. So just PV equal to M R T. Okay, so pressure we literally don't know. So V equal to M R of T of P. Okay, so V of E equal to mass. So mass, both mass is 0.5 kg, so 1 kg into R. Okay, R we need to calculate. So because R of nitrogen and hydrogen is then R of mixture equal to this one divided by M of mixture. Wow. So what is M of mixture? M of mixture equal to x1 bar of M1 plus x2 bar of M2. This is molar mass, or M, it means x1, it means we can just go M of mixture is 1 by x1 of M1 plus x2 of M2. So 1 by 0.5 divided by 28 plus 0.5 divided by helium. Helium is 2. Okay, just 2 will be, I suppose. So next one, about this one is just go as it is. So R of mixture equal to 8.314 kilojoule per kg Kelvin divided by this entire thing. Put here this entire thing and calculate. Then R of mixture will come. Put here R of mixture into temperature is 300 Kelvin divided by pressure. So divided by VP. VP is 1 kg into R of nitrogen is R of this one is 8.314 divided by 28. So put here 8.314 kilojoule per kg Kelvin divided by 28 into temperature is 400 Kelvin divided by 2 times of PP gets cancelled. I think so I can easily do it. Dun, 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 dun. Okay. Okay. This one comes here. Okay. Oh, helium is 4. Oh, H2. Okay. That's what I was confused. So this comes 6. Okay. Helium is 4. Good question. So you can just go for the next one. If the barrier is removed and the gases are allowed to mix, then the final temperature. Okay. Rigid insulator. Okay. Insulator 380. So no work done because internal energy will be same. So M C V of T final minus of T I, it means this 300 plus M of nitrogen this one nitrogen plus of helium. So Cv of T initial, it means 400 Kelvin minus of T final equal to 0. So Cv, you can see this one Cv you need to add Cv of helium plus Cv of nitrogen. So 742 plus of 3102. Okay, add this one and calculate and find the temperature change. Okay. What is this? Sometimes 0 point equal to 0 point plus. Okay, you can just calculate, that's it. Okay, not a big issue. You can just go for this. It's asked in 2012 GATE XE. Okay, so initially contains 150 kg 400 arrangement to ambient temperature, characteristic gas consumption of air. Okay, the cylinder wall has collapsed. The cylinder wall has stoppers of negligible thickness that can prevent the piston from moving down. The stoppers are 1 meter from 1 meter. So at the initial stage, the piston is resting at 1 meter above the stops. Okay, I'll just say the piston is shown in the arrangement is allowed to cool to the amp. Okay. Okay guys, now two process will be. Okay, so definitely your constant pressure process won't be. So you can see one upper portion, as we are just cooling, the pressure tends to drop. Okay, as the pressure drops, definitely the constant pressure won't be. Okay, so you can see next one pressure drops. Okay, constant volume will be, because after this the air stopper is there, so while it comes here, so constant volume, this only constant volume process. So Q equal to W plus of delta U. Okay, is it given rigid? Okay. So good question in my point of view. See, in my point of view, I think so. While the temperature has been reduced with constant pressure, means what is that? So first process might be constant pressure process, the next process may be constant volume process, I suppose. Okay, because you can see while the temperature has been decreasing, so the pressure tends to reduce, but there is a piston here though that pushes it downwards. Okay, while it's been pushing it down, so you can see the volume reduce. Okay, definitely in first the constant pressure process will be, next only the constant volume process might be. So how we can just do constant pressure means, so here Q also did not given, so Q equal to mCp of delta T. So mass we know. So for example, P equal to mR of T, and the pressure is given 150 kilopascal. Volume is given volume. No, it is given 1 meter square. This one. So we don't know this area. If we know the area, we can just calculate the volume. So volume equal to mass this also we can't do. just think guys, literally easy question only in my point of view. Suppose if specific volume is a second P specific volume of RT also, you can see the final pressure will be, so let us calculate. Let us suppose the specific volume, it means P1 specific volume of RT. Let us suppose like this we can calculate. Constant pressure means V1 of T1 equal to V2 of T2. Okay, so V1 is the entire one, V2 is the smaller one. Okay, here the T1 will be total and T2 will be, so for example, so let us suppose the volume is mass is 1. Let us assume like the mass of air is, so volume equal to R I think so you can definitely know R is R of air is 0.287 kilojoule per kg Kelvin. So mass, okay, into temperature is 400 degrees Celsius, 273 or 400, so 673 divided by pressure is 150 into 10 power 3 Pascal. So V1 we just found, it means total volume. So based upon this one, it means temperature T1 is 400 degrees Celsius, T2 is ambient 20 degrees Celsius. Based upon this we can just find V2 volume 2. Okay, so later on volume 2 is constant. So after coming to this one, you can see volume 2 we just got. So what will be the pressure? So after we got the volume 2, you can see P2 V equal to RT, R into T. So this is ambient. So V2 we just got, P2 equal to R of T of V2. Okay, by this we can calculate the P2. So specific water Q equal to W plus of delta T. Okay, so delta U. So this one MCV of delta T, since it's given specific entirely mass only. Okay, so but my question is, where is Q? Okay, it is given digit also, is not a problem also. They haven't given here digit. Okay, so heat, so delta T is 400 degrees Celsius minus of 20 degrees Celsius. It means convert to Kelvin. So CV you can definitely put here and you can just calculate. So this one comes to side means you will just get the answer. So first one is isobaric heat rejection. Second, okay, first one is what I just told. Just a simple thing they just took. Okay, it's so simple only. So however it means, let us divide P1 of P2. Okay, P1 and P2. So P2 divided by P1 is R of T2 divided by V2 divided by R of T1 of V1. Okay, so P2 divided by P1 is R T2 divided by V2 into V1 of R of T1. Okay, so R gets cancelled, so V1 of V2 T2 by T1. Okay, that's it. So that's it guys, same thing I just told about it. Okay, so next you can see, so this might be an interesting thing. Okay, W1, the entire it means the entire thing. You can see this one, since about constant pressure process and constant volume process. In constant volume the water will be 0. Okay, but work done for 1 to 2 is P V2 minus of V1. Okay, pressure why is calculated like this. Okay, so suppose if we calculated V2 and V1 means we can directly put here, and pressure we have known 150 kilopascal, or by case of scenario M or T2 minus of T1. Okay, so put here M equal to R T2 minus of T1. Okay, இதெல்லாம் தேவையாடி. So simple thing, they just written in a different format. So T2 by T1 minus of 1 of into of T1. Okay, so you can write this one because since pressure is under V1 of T1 equal to V2 of T2, they are written in this format and they just say. Okay, I think so we can just go for the next question. So time waste only this. Literally we want to complete the question soon. Maybe next class I need to complete. So we need to just go for the 5th, 4th and 5th. So I don't want to waste the time. Okay. Next thing 27. So 1 kg of dry insulated tank volume. Okay, 6 watts capacity for 10 minutes. Okay, the kind of thing. Insulated. Okay, W plus of delta U equal to 0. So W work done. Okay, so 600 watts, this one delta U. Volume is constant. Okay, P1 divided by T1 equal to P2 of T2. Okay, so this one 600 watts is joule per second into 10 minutes. Minutes is 60 seconds. So second can cancel, and this thing mCV of delta T. Okay, PV equal to mRT. Okay, how we can just convert mCV of delta T. Suppose put the volume this side and R this side. Constant volume process. Okay, so PdV work done definitely. Okay, so PdV volume constant divided by, yes, R will be constant, so P1 of T1 equal to P2 of T2. But how we can just put this in this equation? Simple thing only, just but I can't think now. Okay, so you can see isostatic heat addition to the perfect gas. Okay, Q equal to V P2 minus P1 divided by gamma minus 1. Put here and calculate. That's it. So you can see this thing. So W work done equal to this one W divided by Q equal to gamma minus 1 by gamma. So gamma of air is 1.4. So Q, they just asked about what is the pressure change. So what is the work done? Work is M or T2 minus of T1 by delta T. So this can be written as P2 V2. Okay, there P1 like this one. Volume is constant, you can just put. So P, it means delta P of E equal to M or T2 minus T1, just Q0. Okay, I think so you can do it. So I'll just show you the question again and I'll just explain you. Where is the term? Isoporic. Isoporic, I just start with the isobaric. So isoporic is one, so MCB of delta T. Okay, isoporic heat addition, QB MCP of MCP of delta T put here, and I think so you can V P2 minus P1 divided by gamma minus 1. Okay, calculate the answer. So next question, you can see the mass and internal energy will be written specific in the H equal to U plus of PV. So specific volume equal to volume divided by mass. Okay, so next thing, next thing you can see about this one. This one. So the specific of constant volume. So CB they are asking. So CB minus of CB equal to R. Okay, R we can just easily calculate. It means R is R bar divided by mass, molar mass. Okay, so R bar is I think so you would have known, and with anything so you can just calculate R bar, molar mass, calculate R, put the R here, and CP given, so CP calculate. Next about this one. So U is 200 0.718 T, PV 0.287 T plus of 273. Specific heat. Okay, they are asking the CP so much. Maybe PV equal to M or T. So temperature we don't know. Yes. So U is 200 plus 0.718 T. Okay, so U is U plus of PV. Okay, so 0.287 T plus of 273 equal to 0.718 of T. Okay, so calculate this one, calculate the T. So after calculating the T, what will be the thing? Specific CP they are asking. So mcv of delta T, okay, or U equal to enthalpy, so enthalpy to mcp of delta T, okay, or delta T or temperature, okay. So temperature, you can see H is 200 divided by T, temperature put and Cp you can calculate. So Cp is dou H by dou T with respect to pressure, okay, H equal to U plus of PV, okay, TH divided by dt. So U, I think so you can, so differentiate with respect to temperature, so each and everything, and put, and you can calculate the everything, okay. So equal to Cp. So good question, okay. In my case scenario, it's a little bit quite different, that's it. So you can just go for the next question. So you can easily do it, guys, because it is an insulated cookie. So just directly mcv of delta T, okay. So T initial, you can see temperature initially given, so easily you can do it, okay. So next question, you can see if a piston is free to slide without any friction, the parallel will give us the final temperature. You can see this one, delta temperature of volume equal to delta this one, constant put and we can get. So isobaric heat addition, this one cube, okay, each and everything same, so little bit the change will be, okay. So that's it, okay. This way you can understand. So delta of temperature change of volume equal to delta of comma of delta change of temperature pressure, okay. Okay guys, then that's it for this video, and I hope you understood, and let me see you in the next one. Until then, take care, bye bye, have a good day.